Consider a conducting wire of an arbitrary shape carrying a current I. One can consider the wire as made up of elements vector dl1, vector dl2, and so on to vector dln, each of an infinitesimally small length, so that each element is a segment of a line vector in the direction of the current. One of such elements is shown in the figure, which also shows the position vector, vector r, of a point P with respect to this line element. The magnetic field vector dB at P due to the current I in the element vector dl can now be found by using Biot-Savart's law. The Biot-Savart's law, it states, the magnetic field produced by a current element I vector dl at a point with position vector vector r with respect to the current element is given by vector dB is equal to mu 0 upon 4 pi cross I vector dl cross cat vector r upon r square. Here, I vector dl is the current element, that is, the product of the current I and the small length vector dl of the conductor, a vector quantity directed along the current. Mu 0 is the permeability of vacuum, that is equal to 4 pi into 10 raised to minus 7 Tm per A. Cat vector r is the unit vector in the direction of vector r. The direction of vector dB is that of the vector product of vector dl and vector r perpendicular to the plane formed by vector dl and vector r, and in this particular case into the plane of the paper. The total strength of the magnetic field at P can now be obtained by finding the contributions by the individual current elements and taking their vector sum. As the line elements are distributed continuously, the vector sum can be represented as line integral as vector B is equal to integral of vector dB, that is equal to mu 0 I upon 4 pi into integral of vector dl cross cat vector r upon r square. Vector B is equal to mu 0 I upon 4 pi into integral of vector dl cross vector r upon r cube. Note that the Biot-Savart's law is an inverse square law, like the Coulomb's law. Using Coulomb's law, we can find the electric field at a point resulting from a distribution of charges. Similarly, using Biot-Savart's law, we can find the magnetic field at a point resulting from current distributions.